Welcome to our Research Jam. So Research Jam is this event where we get together and talk about research directly. Our other events are more on the peripheral of research. We'll talk about papers. We have casual chats about research directions. But this one is we have presenters present their research updates, and we actually dive into the research progress. So today is a cozy meeting. We have two presenters talking about rather different projects. Let's get started. Also, before this recorded part of this meeting, we have had a little open mic. So next time, if you're watching this on YouTube, try to join real time. It's more fun. And also, I don't think many people actually watch recordings, even though they promised that they would. So, Papanini, if you're ready, we can start with you.
Today, I will be talking about a short and interesting topic I've been working on for the past few weeks. And it's basically asking the question, can LLMs power product recommendations? Just like we know that traditional recommender systems approaches, we know the collaborative filtering, we know the content-based filtering, and of course the hybrid and things like that. But using the power of LLMs, what if we try to fine-tune it so that we can ask LLM, Mr. LLM, this customer purchased this days ago, purchased that as well. So what product or what material is this customer likely to consume or purchase in the next few days or in the next 2 weeks, for example? So that is what this project is about. So basically, the objective is to just investigate the potential of LLMs for recommender systems. And then one key task used to test the efficacy and the performance of the model is that, oh, Mr. LLM, could you please predict the next 10 items a user may likely purchase, given that they've purchased these particular items in the past and given this particular material information as well. And for this project, I used Amazon appliance reviews data. So this data contains user reviews, contains also the product metadata. And from these user reviews, we can also filter and check if a customer actually purchased the products that they are actually reviewing or not. And this is just a short statistics of the data about 1.8 million users, 94,000 items, and the rest. And
Bob, in that data set, do you capture whether a user purchased an item only if they reviewed it or even if they did not review it?
So in this case, for training, I filtered it to be items the user actually purchased. So they actually purchased. For some of the ones they purchased, they have some reviews about it, but for some of them, they may not also review it as well.
Okay.
So, and then with that, where LLMs come into account, even if a user, for maybe future or for any test data that the user has not seen, the model has not seen, even if a user has never purchased or even reviewed a particular product, it can predict if the user is likely to purchase that product in the future.
Cool.
Yeah, and then this is just a short problem statement I just made up that, of course, we all know traditional recommender system, there are various approaches to solving them and relying on maybe how we want to use it, collaborative or content-based filtering. But of course, the usual code start problem, scaling, sparse data, and also understanding user intent. So we know since LLMs can capture this semantic information from these user reviews, can they provide personalized recommendations? That's looking at, my goal was to leverage the natural language understanding capabilities of LLMs to predict which items they are more likely to purchase in the future. So, and one thing, just a disclaimer, the goal of this project is not to optimize for high prediction accuracy or anything, but it's just to learn if LLMs can effectively be applied to recommender systems problems. So it's not, I'm not optimizing for performance or anything. So basically, the data could look like this. This could be a user input. So after structuring using the 5-3 style prompt. So for example, what I did was I allowed the model to no users. For example, user 1, user 2, user 3, user 4, and things like that. So they are encoded as special tokens. Similarly, items as well are encoded as special tokens so that the model can understand them. And then, so this could be an example of a data point. So this input means this is how I encoded the user. This is the user ID. Then this output here is saying, oh, for this output is saying this is the item this user purchased next at this particular point in time. Because one thing is very important, so of being a trained statistician, so I have to be ensure that there is no form of information leakage or data leakage. So it's very, very important to take into account the temporal nature of time. So that we looked at today, for example, let's use today, for example, if a user between January to August training, so then it could be like September could be validation, then of course future, we don't know the future, so it can predict what will happen in October, November, and December. So I kind of handle this with care to ensure there's no information or target leakage, because LLMs can be funny, they can peek into the future if one give them that opportunity to as well. And this is just an example of a data input. So you can see the instruction was quite simple using the Phi3 style prompt instead of alpaca, because of I was using GPT-2 medium, which I downloaded the weight from OpenAI. And then, of course, item ID is this, rating of the item is this, text of the user review is this and that. So I think I have a few minutes more, but in summary, so the methodology is quite simple. The model was GPT-2 medium, and then using these are the embedding dimensions, the number of layers 24 and the number of attention heads. And then on the right, we can see the training and validation losses over 2 epochs. And we see that after at one epoch, the model, the validation loss is quite okay. You're going on the expected path a bit, not on average, it's like not that significantly different from the training loss, but after one epoch, we see that the validation loss is trying to overfit as well. And then, so the data preparation is quite simple. As I said, for each user, we predict the next items they will purchase in the future. So using time splitting, cross validation to ensure there is no information or data leakage. And also what I call handled padding, it means that this padding, I kind of have different alternatives. For example, what I call repeat last item, special token. What it means is that imagine that a customer or a user purchased a particular product today, being September 18th. Now we say, as of today, what is the next 5 or 10 items the customer purchased in the future? So this is on the data preparation steps. So imagine if throughout the customer lifetime, you do not even purchase up to 10 products or 10 materials. So in that case, just like in this example here, we can see that in that case, I use a special token called end of text just to pad it, so just to let the model be aware. Well, this customer did not purchase anything after this particular item. And then, so it's quite simple as well. I think I've explained this earlier. So the input, I said the input, I just set it as a user ID. So then the output becomes the next 10 items purchased by the user, encoded in this format, item ID. And then the prompt is quite simple as well. I just say, given a user purchase an item with the following details, predict the next item the user would purchase in the future. So for example, for instance, in this example on the right, this is example of a model's response on the test data. So this is the input is the user ID. Output, this is the item the customer purchased, B07 something VDSP. But now, what the model is predicting that this customer will purchase is these different items. So as I said in the start as well, what this approach is doing is we are trying to predict the exact SKU that a customer is going to predict purchase in the future, which is quite difficult because it's not, for example, let's say a customer, if the model knows that a customer will likely buy a toothbrush. So we are trying to predict what specific brand of toothbrush. So, it's a difficult problem that the customer will purchase in the future. So, because there are many different kinds of toothbrush as well. So imagine we were to optimize for model accuracy. Instead of predicting the exact SKU the user will purchase, we could maybe predict product category. In that case, of course, the LLMs would do better. But because of our time,
Hey,
so
Babs, when you're scoring, when you're giving a metric or computing the loss, do you require that the order is correct, or is it just the set of 10?
So in this case, that's why I used various metrics as well. So first, for some of them, just for example, things like precision does not take into account order. But if you look like metrics like mean reciprocal rank, that takes into account position. So in this case, I'm not focused about the order of predictions in this case. So I'm not
Well,
focused on the order of predictions. I
earlier
just want to know if it can even predict it itself.
earlier you showed a loss plot. Is that loss the standard training loss? So I guess that loss would include order.
Yes. Oh, okay. So this loss is the cross entropy loss. So
Right.
this cross entropy loss is looking at the 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 difference, or should I let me just say the distance between the
This
output.
depends on order though, right? Like, do you have
So
any
this,
metrics?
yes, because it's predicting next word. Yes, if we look
Yeah.
at it, it's just like autoregressive. I don't know why we even call it language models. It should be like autoregressive prediction model.
Yeah, it is exactly that,
Yes.
right? Do you have any plots of metrics where you don't care about order?
Currently, no. So this is because, I mean, the way the loss works, since the loss function being used is cross entropy loss between
Right.
the predicted next items and the actual items. So it's
Right.
just like predicting next word, in this case, predicting the next items. So in this case, that's what it's doing, predicting the next items.
Yeah, I
So
think this is a great maybe training objective. So you should show this plot, and this is perfect. The question is, after you train a model in this way, how good is it at predicting things where you no longer score carefully with the order? So maybe you could show in the same plot, the same epochs on the x-axis. On the y-axis is like just a subset overlap, for example, of the products that are purchased versus the products that are predicted. Also, I'm curious, how many products are in the data set?
I mean, there are quite a lot of
I think you
them.
showed, but
So the data set
4K.
contains about 94,000
Okay.
items.
So as a
So
baseline, as a very simple baseline method, what if you just predicted the top 10 most common items in the data set? Like
yes,
what metric would that correspond to? Is your loss already far better than that, or is your loss only barely approaching that? Right? These are very different worlds. It'd be nice to see which one we're in.
yes. So those are actually the next steps as well. So that was
Okay,
actually the
cool.
first thing I was supposed to do, like looking at some baseline, which I intend to do. I just completed this on Sunday. Just completed running this project on I think on Sunday or which day evening. So that's
Nice.
why I'm like, oh, okay, I'm excited to share today.
Yeah,
So it's
yeah.
still something that's currently ongoing, which I intend to, compare it with different baselines and also compare it with traditional approaches as well. So I intend to do that as well.
Cool, great.
So as of now, as you also suggested earlier, so maybe if we are not even focused about the order in which the model recommends, maybe any other and things like that, maybe it will even perform better based on the evaluation metric we use. So that's
I
what
would say even maybe a more subtle point is these numbers look low, 2.2%, 5.4%, but it's actually very hard to tell whether those numbers are in fact very low or great, right? If you have a product database of 94,000 products and all of them are equally uniformly purchased and you're managing to predict 2 or 5% accuracy, that's actually very good. If you have 94,000 products and nobody buys any of them but the top 15, then these numbers are very bad because you could have just predicted the top 10 or 15 or whatever, right? So I think if you compare to the simple baseline approach, it would really help.
Yes. So, and that's the also next step after this as well. Thanks for your contribution, Jason.
Yeah, cool.
And in summary, so I know confidently, I can say I know that, LLMs can understand user intent and product details, and there are opportunities for further fine-tuning and improvements as well. Yeah, I'm just using GPT-2 medium. So maybe I could even use GPT-2 large and things like that to improve things like that, just fine-tuning or maybe a stronger model. Now it's just GPT-2. I'm not using anything fancy. So maybe if I decide to make something more fancier, and also, of course, we see that the low recall suggests maybe the model struggles to predict the next exact items. And then also because this, from the data, there is nothing regarding user information as well to take into account contextual information. So there's nothing regarding user information. So we just know user ID. So and user ID purchased this at this time. So nothing regarding the user themselves. And so next step is first baseline comparison. I intend to compare it to traditional recommendation models and even simple baseline like popularity model, like, oh, the top 10, for example, most purchased, or top 20 and things like that, and see if maybe this evaluation metrics aren't that bad overall. Maybe they're even doing better than the baseline comparison as well. This was supposed to be the first step, but actually I was very excited to try this. So since it's a personal project, I wasn't like focused on the baseline because I know I can always do that. Maybe that's the laziness part. And then, yeah, these are the future improvements. So the takeaway in summary, we know that the LLM-based recommender system shows promise, but require further fine-tuning and benchmarking against baseline methods. And of course, there are opportunities for future research. And to crown it all, as I said earlier, the primary focus of this project is not just to maximize performance, but to explore whether LLMs can offer an alternative approach to recommendation problems. And yes, thank you. That's all on my end. Any questions, please?
Yes, I was wondering, like, what is the end goal of building this solution? What action is it going to trigger once you predict the next 10 items a user is likely to purchase? Are you going to, send him personalized product recommendations or optimize cross-selling? Or how can the business benefit from your findings?
Oh, thank you. I guess in this case, it's the typical business application of recommender solutions. So first, it could be personalized recommender systems. So it could be recommendation, sending user personalized recommendation. And of course, things like this, if let's say marketing departments, we send the result to marketing departments that we can accurately with a certain level of confidence predict what user is going to purchase, say in the next 6 months. Of course, marketing, we also design personalized interventions to actually reach those customers quickly. And also this could also help with things like inventory. We know what quantity of inventory to stock in our warehouses or maybe online, or depending on the kind of nature of our business. So it is quite wild. It's the typical application of recommender system solutions.
I have a question back. Have you
Yes, please.
explored, like, when you're asking the model to predict, have you explored different prompts and see if there are any changes in your 10 items that are predicted?
Oh, wow, thank you. So yes, regarding that, I currently majorly use two prompts because there are two majorly prompt styles. There's one called the alpaca prompt style. So because I want something universal, like instruction that is quite universal. So currently I'm using I set it this way using this I think it's called 5-3 style guide, because of course the more prompt information you give it, the more resources you need to encode this information. Because for example, if you look at this training data alone, these are lots of text already. For example, item ID is this, rating is this, text of the user is this, main category is this. These are lots of text already. So imagine adding more longer prompts, of course, which is quite good, but then you need more resources if you are training with a GPU, for instance, and then also things could get very, very slow. So for now, I'm just using the alpaca style prompt, and I'm using just this basic prompt style, like, oh, giving a user purchase an item with this generally. Of course, it can be improved. Yes, it can be improved.
No, I didn't mean to improve it. I just asked if you had a chance to explore different prompting styles. So you could, like, be very specific about, like, can you take reviews under consideration? And I don't know if that's possible. Can you take reviews under consideration so you can stress the model to look at the reviews for the order ID that the user had placed already, and maybe more maybe see if we can increase the recall score and the precision score by looking at the reviews the user has placed in the past.
Oh, thank you. Thank
Something
you.
I would
So,
explore.
yeah. So I can share the link to this project on my GitHub. You could contribute. Currently, I make it editable. There are only two prompt style like Alpaca and Phi3 that I'm currently using. So that can be used currently, but of course, it could also
Yeah,
improve.
thanks. This is great. Thanks
Thank you
for
very
putting
much.
this together.
Just quick eyeballing the size of the data. There's so many
Mm.
users. Looks like the
Mm.
number of users is so much more than number of products. So I was thinking
Yes.
you don't even need to include the user ID because probably they're always unique. And by including the user ID in your prompt, in your input, might confuse the model, make model try to memorize this string when it's actually never going to encounter that string again. Just wondering.
Yes, I get that as well, but because I thought about that, and my idea was that I wanted the model to give a personalized recommendation that given a user, what recommendation will it recommend for that particular user? Because I don't want the model to kind of hallucinate that, oh, maybe it's a recommendation for every user or for everybody. So
Yeah.
that is why I had to also kind of include the user and give it as
I
an
get that.
input.
But I think maybe the model want is the user's characteristics other than the ID. But of course, I don't know if we have the characteristics, but
No, I
even
don't.
the review itself is pretty strong feature already.
So currently we only have in the data basically just have user information and product metadata. So user reviews data and product metadata, nothing regarding the user or anything on contextual information on the user.
I think Roseanne's making a really good point. So you model, you probably don't want to take specific user information about every specific user and bake it into the model. You probably want to have the model learn the relationship between user characteristics and what they tend to purchase. So if I was you, I would do this exact research trajectory. So I would start with a baseline, like we said, predict the 10 most common products. Let's consider some other models that are maybe simpler than what you're doing, but might be elucidating to see how well they work. So one could be, rather than giving the user ID, as Roseanne is mentioning, this might not be memorizing what you want. As the input, give this user's reviews. So for a user that provided the following reviews and then list out their entire review, right? Maybe it's really long, but that's okay. What products do you think they'll purchase? And then the output should be the correct products. Okay, another, so that's a simple model you could try, which does not require the user ID anywhere. Another simple model you could try would be, here is a user with the following purchase history, just give the products that they purchased in the past. What product will they purchase next? And then ask for the 10 next products. So now this model can probably learn actually some pretty powerful stuff. So people that tended to purchase all these gadgets for their cars, right? They're probably going to purchase these other new gadgets for their cars that they haven't purchased yet. Or, right, books, purchase more books. So a model that can learn these types of simple relationships is probably already going to do better than your baseline. And you might find that it already does better than this model you have that memorizes user information.
Thanks for the input as well. Thank you. So I also have to consider the maximum number of tokens the model can process.
Sure.
As well.
Right. Always tricky.
Thank you.
It's still pretty amazing that using a GPT-2 to get things running and loss going down. That's a good sign.
Should probably move to the next speaker.
I think this is maybe the second or third time that JU has come to talk about the same project, if I remember right.
Yeah, this is my second.
Yes.
So last time I presented back in April, sort of presented this idea I had for a new way to design a web navigation agent. And the goal is basically to have an LLM based agent that kind of, like prompts an LLM continuously in a while loop and then the user only provides a high level goal to the agent of a task to complete on a website. And then after that, the agent tries to complete the task on its own just by, clicking and scrolling through the web page. And for example, for Twitter, the user might just give a task like, please bookmark all Twitter posts that fall into a certain category. and then the goal of the agent would be to click the necessary page elements, until it like decides like it thinks the task is complete, and then it ends.
Hey, can you make it a little bigger? Maybe slideshow mode or?
Yeah, sure.
Thanks.
So, and then in order to allow the agent to, like allow the LLM to observe the website screen and interact with it, we need to provide some sort of like that allows the agent to like read the website information and then click different links normally using function calling. And I'm just gonna skip ahead a little bit. So yeah, so like what I learned from working on this project for the past few months is like, even with the same LLM, like, performance can be drastically different, even on the same website, depending on how exactly you present the environment observations to it. And like the simplest approach is to just like download the entire web page HTML and then just give that all as text to the agent. But that's usually like way too many tokens to fit in the context length. So what most LLM agents implementations use, like to allow the agent to interact with the web page, is like they generate an accessibility tree from the website DOM, which is like it's just like programmatically generated from the HTML of the web page, but it's just like more like pruned to only like it just prunes out a lot of the unnecessary like text from the HTML. And then so for example, like here, like the navigation part of this accessibility tree are like just all the like links in the top navigation menu, and then in the bottom parts,
how is this tree created?
It's like for Google, for most browsers, they just have a like functionality to automatically generate it, like programmatically. Like it just uses some like heuristic rules to like like parse out like most of the HTML like metadata and like syntax stuff, but it just like keeps like like the main like I guess like important information, I guess. But
have you seen, is this usually a pretty faithful representation?
Yeah, it's like it's usually faithful, but it's also kind of like still like I would consider this like not as optimized as like it can be. Like for example, like just to like represents like these like few buttons on the like top of the screen. There's a lot of like like nesting and like a lot of like random like unnecessary text. And then now that like vision LLMs, like multimodal LLMs are getting better, like the other option for providing the web page interface is to just give it a screenshot and then most multimodal web agents, they use what's called like a set of mark interface, which is like, basically like you can they just use either like some like JavaScript or playwright functionality to just like highlight all the clickable elements on the screen and then like draw a bounding box around it with the numbered label. And then given this screenshot, the agents like you just ask the agents like out of the clickable elements on the screen, which one do you want to click? And then you can just if it wants to click like anything, it just says like which number box it wants to click. And this has the advantage of like like getting the visual information of the screen. There's a lot that's like not like, encoded in the text representation, but I guess the main downside of this approach is like like if there's a lot of clickable elements on the screen, like, you know, the interface can get like kind of crowded with like just a lot of, you know, stuff, like extra stuff added to the screen, and you know, it might like somewhat obscure actual like web page details. And then if you make the labels like too small, maybe the LLM won't be able to like see all of them. And if you make them like too large, like, you know, they might like take up like too much space on the screen. So what I've like done instead is like, go back here. This is what I like presented last time. Like, my initial idea is like, instead of like having the agents like try to read and understand the entire web page screen at a time, like just tell it to first like divide the screen into like different sections, and then after it divides the screen into sections, it zooms in. Like I just like crop the screenshot image and have it like zoom in on each different section one at a time to like analyze like each section in more detail. And then like this has the downside of like taking like more time and like more LLM calls for like each screen, but like it's like I would consider it worth it like most of the time, since it allows the LLM to, you know, like get a much more like accurate understanding of the screen. So yeah, basically what I do is like I like first divide the screen into different sections and then zoom in on each section, and then I just have the LLMs and VLMs. They're like quite good at generating I guess like summaries, large amounts of information, and like into just like kind of, you know, compressing it into the main details. So this is the kind of like the summary it generates for the web page like earlier. Like so yeah, it first divides the screenshot into like, you know, kind of like the major sections, and then generates like a summary for each section describing like, you know, what the purpose, you know, like what different elements are contained, like different functionality each section has. And then like doing it this way, like I guess like the information of the web page ends up being like a lot more readable and a lot more like concise compared to using the accessibility tree. Like this is like already like more text than the summaries, but like, you know, this is not even like for the whole, this is just for like the top section of the web page is like all this text, but with the summaries, like, you know, it's just like 1 or 2 sentences for each section, and then like these 5 summaries here like pretty, I'd say like pretty accurately describe the entire web page. And then after it does this, like it analyzes each section in detail, then the LLM basically gets to make a choice about like which section it wants to like focus on. So like depending on, it's like depending on what it wants to do, like if it wants to, you know, like go to the account settings, like, you know, it can, the LLM will just like choose, I want to go to section 0. Or if it wants to like you know, look at one of the images on the screen, it'll like choose the list section. And then the only real downside to using this approach is like, you know, it multiplies the inference time. So yes, since it's like dividing the screen into multiple sections, like for each page, it does take longer, but it's still not too long. It's roughly about like 30 to 60 seconds to analyze the full page usually. But so basically like that motivated me to like kind of like since the agent is going to be visiting the same website and like the same pages like over and over again usually, like then like, you know, you don't want to do too much like repeated computation for the same page. So basically what I've been working on for the past few months is to add a long-term memory system to the agent, that so that like after it does its like detailed analysis of a web page, it then like saves its analysis in memory, so that like if it visits the same page again in the future, it can just like retrieve its memory for that page, instead of like, splitting up the whole screenshot again and doing the analysis. And then another thing I added to the agent is like, I thought like since it doesn't take that long to like analyze each page, so like I decided to have the agent like, when it encounters a new website that it hasn't seen before, I have the agent like do a quick like exploration phase first, to kind of like navigate to different pages on the website and like learn the overall structure of the website. So, and it doesn't do like full exploration. It's, like most real websites have like way too many pages to like, like navigate to every single web page and like memorize every single one of them. But for most websites, like they keep like, I guess like all the important like pages accessible on the like top navigation menu. So yeah, basically what like the agent does is like, every time it visits a new website that it hasn't seen before for the first time, it'll first click and navigate to every single one of the links in the navigation menu, and then it'll do its full analysis for every single one of those pages, and then save them in memory.
What do you use to save them in memory in this database?
I just created like I guess like a custom implementation of a knowledge graph, I guess. I just like encode everything in like I save everything into like JSON object files.
Mm-hmm.
And like each node of the graph is basically just like a web page URL, and then it saves LLM summary of the web page and all the major details, and it also encodes the edges between the different web pages. So like it starts on the home page as the root, and then it'll try clicking each of the links in the navigation menu to do its exploration. And then like each new page it visits during exploration, it'll like save a new node.
And then
Like,
wait,
just-
so in later steps of the task, do you feed this whole graph into the model?
No, it only like retrieves the current
I see.
the current page it's on.
Okay.
Yeah, and then so basically doing this exploration first, like like navigating to like all different major pages of the website first before like like trying to do tasks on the website, it basically makes it much easier for the agent to like find the web page it's looking for, since like normally like if the agent's just like starting from a blank slate like without any previous memory, it kind of just has to like if it wants to find a certain page on the website, it kind of just has to like read the names of the links and like make an educated guess about like like which link it should click. But like since the agent like does the exploration first, it already knows like what information is on each of these pages. So after it does like its exploration, then when it's actually like trying to do tasks, it like first it looks through the pages that it's previously seen in its memory database, and then it can like choose which page it wants to go to, and then once it navigates to the page it wants, like then like once it's on the page it wants, then it's presented with the list of like different sections of the website, and then it can choose which section it wants, and then like after it chooses like one of these sections, then it's presented with the list of like different elements that it can interact with.
Have you done any tests maybe to show that this is beneficial versus I guess a more naive approach where the agent just sees the web page and has to make a decision one page at a time with no other information, no other context?
I haven't run any like full benchmark runs, but I've kind of just been doing like ad hoc, I guess, like, like.
I mean, it seems like it should help. It would be interesting to see if you had any benchmark. I guess for that matter, how would you define a benchmark here, even for your own?
Well, like mainly, there's quite a few like good benchmarks like that have been released for this task recently. Like this screenshot is from the Web Arena benchmark, which is like kind of, I guess, the main most popular benchmark these days, because like it's like a simulated like all these websites are like completely hosted like locally, like, and it's kind of just like a simulated or they have like multiple simulated websites for like Reddit or like or shopping sites or stuff like that. And yeah, like I guess the goal is just to improve scores on like those benchmarks.
What exactly is being scored?
Well, they have it's usually a success rate. The benchmarks like have a
Clicking something?
Like the benchmarks have like different tasks, and then they have functions that can check the HTML state to see like if the task was completed successfully. And then like the evaluation is just the average success rate, like how many tasks were like completed or not completed.
So you haven't gotten to the part where you are making actions on the site yet, right? So far, you're just reading the site, organize them into a structured knowledge base. Have you completed the loop of like now click some button and make the HTML change?
I already have all the clicking implemented and stuff. Like I just use the Playwright for so like
then you can really compare whether your VLM based web scraping and knowledge structuring is better than just like simple HTML and this accessibility tree, right?
I haven't tested with state-of-the-art models yet, but like I've mostly been using open source models for this so far.
Yeah, the model matter. I'm just stating, since your innovation here is that you use a VLM to summarize the site into a more human readable format. But then the question is, does this format help the actual task completion? Because maybe machines prefer a machine readable format and not a human readable format, because natural language is so fuzzy and imprecise. And I'm just putting ideas out there. So maybe the model would prefer reading just the whole HTML tree, even though it seems like very confusing to us. Maybe it's clear to the model. But basically, eventually, what you want to evaluate is just the task completion, which format helps the task completion rate.
From the models I've tested, they much prefer, I guess, like the summarized version. Since you are right in that like the HTML contains like more extensive, like more structured information, and but like the only real downside to using like HTML is like exceeding like maximum like context length of models, which like it might not be as much of a problem for like state-of-the-art models, but like I found for open source models with the lower maximum context length, it's much easier for them to have like more like concise representation.
Yeah, that makes sense. In that case, you might not need to really use a VLM to come up with this. I'm sure you can train a model that maps from HTML, full HTML to this. But of course, you need a model that can take the full HTML. Then you just need a text-only model. You don't need the visual part. Of course, you won't be able to parse all the JPGs in the HTML.
Yeah, I think like there are some like open source models that people have like released for like that purpose, like parsing HTML into Markdown, or like more like just like text only. I think that's I was considering trying that as well, but like I just like did the VLM. I just started with the VLM summary, like kind of. Like, I just like tried it, and it seemed like good enough most of the time, and it was like it's like fairly simple to implement as well. I just like give the screenshot to the VLM and just tell it, like describe this. So
yeah, it's definitely promising to see that the result is very good. It just from the technology standpoint feels like a roundabout, because you have HTML which can be rendered into a web page, and then you take a screenshot of the web page, feed it into a visual model. I just feel like you could have just gotten the whole source from the beginning. But great that this works.
Yeah, like I guess HTML, it can be like sometimes like contain like information that's like only relevant to the functionality of the website, rather than like being optimized for like user understandability. And I guess that might be like part of the reason why like using the VLM summary like works surprisingly well, is I guess like like most websites are designed to be like visually understandable to humans, and like like I guess that makes them kind of like suited for VLMs.
Yeah, makes sense. Then a middle ground would be you pick the part that you think is most relevant. Basically, it's like your screenshot method, but then feed the HTML source code that's only relevant in that block to the model.
Like that's like that's kind of like similar to what I'm doing. Like it gets the summaries, like the kind of the high level summaries, just as like an overview of the web page, and provides like just enough information for the LLM to like choose the relevant section. And then once it chooses the relevant section, then I provide it with like, if it like chooses the navigation section, I provide it with like the HTML elements, the links that are like present, and then it can just like choose one of these and then execute it, like click on it.
I see. Yeah, that's fair. Are you done with your presentation part? Are we open to questions now? And I know I already took time for your questions.
Yeah, that's I went over like all the new stuff I added. I can take questions now.
I guess I'm curious, what do you think you would try to work on next in this direction?
I guess the only real thing like I tested like the kind of like exploration and like memory system, like, and I'm fairly like satisfied with how this is working so far. And I guess the only thing next is to just work on like planning component of the like actually like completing the tasks on the websites, because like now it's the current state of the agent, like it can like do exploration and generate like kind of like a map of any given website on its own, and then it can like given this map, it can like navigate to the page it wants to quite well, and it can also interact with the elements, like just using like function calling. So yeah, like the only thing I have left to add is just have the agent like plan out tasks and complete them, and also when task is complete, and then like stop its execution.
If you did that, would you then be able to evaluate this using Web Arena to see how it kind of...
Yeah, that's the goal.
It'd be really cool to see, to kind of finish a version of the thing end to end, even with relatively unintelligent algorithms stubbed in where needed just to like get a final score. And then you could really iterate on different pieces and see how it improves results on Web Arena.
I think it's I have like most of the like components I need like ready to just putting them together and like working out the just like working out any issues and like, bugs like
Sure.
between the components.
Yeah.
Look forward to see a table with numbers next time, or a bar chart.
Yeah. Like I probably will have like some benchmarks runs to show like by next time.
Yeah, this is cool.
Just to clarify, what Lausanne proposed was that instead of you feeding all the website data through the HTML code that you just scraped it and fed it into LLM, what Roseanne was proposing that you should only use visual language model for that cause, so that you do not run out of context length or memory in case of using LLM, right?
No, the other way around. I feel like using VLM to take a screenshot and read the screenshot is too roundabout, because HTML source code already contains every single thing. It's like you use a rendering engine to make a picture, and then you screenshot the picture and now start reading the pixels. Just feels too roundabout, even though it works. I wonder if we can bypass that and just train this from the source code to the summary with a language only model. And that solves your inference cost, because VLMs are costly. But I think we pretty much arrived that we need some visual cue to guide where the model should be looking at, because that's what humans usually look at once it's rendered. So maybe we arrived at the solution where we need to find the right component and then go back to get its source code.
And what would be the loss function look like for this case?
For what case?
Evaluating the accuracy of the end goal achievement by the agent here.
For the whole thing.
How are you going to evaluate it?
Task completion.
Task
It's not a trainable
completion.
system, right? So far, there's no trainable parts, so there's no loss. Looks like it's an agent that does tasks.
Yeah, it's not there's no like training like currently, like it's it's just like programming, like just like combining like different LLMs into like a program basically to try and solve these tasks. And the way it's evaluated is like there's like each of the tasks is like described in natural language, but the like benchmark environments like basically they have like predefined functions that like check the correctness of a task. So like a super basic example of a task would be, like for this web page, like the simplest example would be like, I don't know, like go to the comments section of this page, and then they would have like a function that like checks the final URL of the agent to check if it's on the correct page when it finishes. And then, like if the URL matches the comment section, then, it's marked as a success. And if it's like not at the correct URL, then it just gets marked as a failure.
Fair enough. Great overall. Great try.
Sorry?
Well tried. Nice endeavor.
Thank you.
If there's nothing else, maybe we should thank JU again, and also Bob's for presenting.
Yeah, thank you both. Very interesting project.
Yeah, cool work. Thanks for giving an update, JU, from the last time.
Yeah, glad to be here.
Yeah, look forward to the next time.
Definitely.
Is there any way of collaborating on this project? Like Babs have started off his project, and Jayu also.
That's the whole point of the Research Jam. So it's called, the full name of Research Jam is Open Collab Research Jam. So people who present are basically committing to sharing their project progress in the open. And I think you can find their contact info from the website, from their slides, and feel free to contact them if you want to help out.
So they are open to such collaborations.
You have to ask.
Any final comments, final asks? Now let's end here. Thanks so much, everyone, for attending and presenting.
All right. Yeah. Hope you guys have a good Wednesday. See you next time.
See you. Thanks, Alex.